All right, good. Well, everyone, welcome. Um, April brings a series of repeated traditions. For example, April showers bring the May flowers, which, based on what happened this past weekend, we should have flowers everywhere in May. The other tradition that happens in April is that we file our taxes by April 15th. That's less pleasant than May flowers, but it's the truth. But in April, we also have a 1-2 series of events. That is our advisory board meeting, we successfully conducted on Friday, and then the week of the SAE World Conference, which is coming now. And as part of that tradition, we have had our friends from the University of Stuttgart uh, come here for many years.
George.
It was Professor Michal Bargende who would come here and invariably would give some kind of a seminar on the Monday of SAE. As Professor Michal Bargende retired, I think most of you know that Professor Andre Pulser became the chair of powertrain at the University of Stuttgart. And he liked traditions, and so he continued the tradition of April showers, taxes, and a nice seminar from FAS. All 30 of the people.
Very kind, Jojo. Thanks a lot. Uh, the showers we already had in Germany already, and it got cold again. Like
Yeah, right. They talk about snow. Yeah, yeah.
Yeah. The taxes I already did them. Good thing. And third, it's an honor for me to, being as was working, but it's a little shop. Share off. Keep talking, then. Okay. Sorry about that. No problem. Yeah. So third point was traditions. So it's a huge honor for me to stand here because Michael Buckner was my PhD advisor over 20 years ago. So it's an honor to try to fill in, only try to fill in its large views, and it's a pleasure for me to being asked by George to hold here a small seminar to give you a small overview from my point of view, maybe a bit of a German and regarding energy, automotive technologies, and the like. So I called my seminar here Sustainable Powertrain Solutions and the role of energy diversity. I like to talk a little bit, especially in Germany, with word diversity, because, and you will see that on my first chapter also, you try to be in Germany very tolerant and bring everything in regarding culture, regarding language, German language also, regarding many topics. And I also think we should fight for diversity in technology and energy topics. And one point we have for sure, and I like this year my talk with Darwin, it's not the strongest and not also the most intelligent. It is the one most adaptable to change. That's what they able to strive. And maybe we can understand that also from the point of view we have many changes, not only generational changes. My kids are 25 years younger than me, and think a little bit different, of course. Not only being my children, they have to think different, but it's a new generation. There are other needs. We also have climate change, technology change. We have many changes, and we have to learn how to adapt to those. We cannot just stand still or else the stream. And I saw the river here in Columbus with a very strong stream. We just can't stand still. So I would like to group my presentation in 3 topics. Start with energy. How is sustainable energy coming and where from? And the second chapter, maybe looking at the circular economy, also to look at a couple of leads, let's say, the boundary between a system. It's not only this system or the people, it's the complete world. So you have to look at it at the holistic way, and then finally go to some recommendations from my side to which technologies we should cover and look for in the future. And right up front, it will not be a silver bullet, of course. It will be some diversity. Again, not everything, but we need a certain variation of solutions to look at problem. And let me again start with the motivation more. So regarding as engineers, we are efficiency freaks. We should be the first ones to look at the future, and from the United Nations reports, we want to meet our needs without compromising the needs of our children and grandchildren. That's one. The quote from Darwin, I already entered, started the presentation for that. And coming also from some let's say, some business family tradition, we have also, as a management role, maintain the ability to act and react. And if we put all our money on the casino on one number, that might go wrong. Everyone knows that. And so it's always good to have a plan B and plan C. So this as a motivation starts here. Looking at some numbers, we know that we have a lot of energy sourced over the last 100 years, and especially in the last 100 years, it has been amazing what we have developed. But that means also that we have from fossil fuel produced a lot of CO2. Say one of the possible, let's say, features to understand energy consumption and climate issues. If we continue this way, it will continue to rise, of course. One step is, of course, to go into new technology, in more efficient technology, yes, but that takes time. If we look at vehicles, in Europe, in Germany, they take like 10 to 12 years to be switched. In Greece, I guess, up to 18 years. And we know many vehicles live over 30 and 40 years. Having been at Porsche for 10 years, one of the slogans at Porsche was that 70% of all Porsche produced are still on the road. Porsche exists since the 50s with building cars. So there are many vehicles that still are on the road. And maybe to go a step further and not only to new technology as an exchange of products, you have also looked at complete circular economy regarding energy, raw materials, but also CO2, and also looking at where the energy comes from. Not only the product being made, but also, let's say, the renewable energy, electricity or molecular nature to, let's say, make the propulsion of these vehicles and the propulsion solutions. So to provoke again a little bit, I saw this kind of sketch last year at the SE Congress, and I found it quite interesting, and I adapted this to my point of view. So if we want to try to go, let's say, just an exchange with new technology, let's say battery electric dissemination, which is a very efficient technology, sure has a wide way of improvements and having very good solutions for the future, especially the topic of the battery. I guess the electric machine is quite well understood for automotive purposes. The battery still is a huge topic. But if we wait to exchange old vehicles by new ones, that would take more time. If we try to be faster, one way would be also to integrate all circular economy topics, additionally the energy. So not only electricity, but also the molecular low carbon fuels, carbon neutral fuels like hydrogen or e-fuels, just any time. So this could be an interesting way if we want to not look at silver bullets, which is of course battery electric vehicles that are a very good solution. But let's look also at other technologies at the same time. If I show this graph from the International Energy Agency, is because it's interesting. Also, diversity will be there. Here, you see on the left, let's say the net zero emission pathway. It's just a scenario, but that scenario shows that over the decades, we would need different technologies with renewable electricity and hydrogen-based fuels running also in different applications. Of course, for light-duty vehicles, it's easier to electrify. Energy-intensive applications like marine navigation are not so easy to electrify, so you have to adapt, let's say, your renewable energy carrier also to your application. And this also shows that diversity is needed in the future. Of course, electrification is one of the parts to go. And there was an update a couple of years later for the IPA. And if one tries to look at it, I'll just throw the pointer. They tried to separate also, let's say, light-duty vehicles from the heavy trucks. You see that till 2030, which is almost so much time, only less than 5 years. For robust development, you always need decades or more to have, let's say, dissemination of innovation into the market. So 10 years is nothing. But you see that even 2030, most of it will be oil-driven, and part of it could be biofuels and hydrogen or electricity. And 2050, this is 25 years from today. So I'm not sure what's happening in 5 years. What's happening in 25 is, well, let's assume this IEA study showing that for, let's say, easier to electrify applications, lots of it will be looking at buses or heavy trucks. Yes, a large capability of electrification is there, but also biofuel and hydrogen, and still a part of fossil phasing energy needed for these technologies. So yes, electrification is important and is an important lever. Let's say neutrality, but also the energy production has to be carbon neutral. So all electricity carbon neutral today, and maybe in 25 years, large part will be, but there is a way to go. And the way to go means that we have to look at renewable energy. And when looking at renewable energy, we actually have a lot of potential. We have looking at wind and solar irradiation, but everything is given us by the sun. Thermodynamics give us wind, so everything is irradiation driven. But with solar and wind energy harvesting, we could have at the moment almost 1,000 human energy consumption per year potential. So we are 3 orders of magnitude below. We could harvest more, but the challenge is that these sources usually are far away of the industrial centers, meaning you don't have the electricity in Germany or in Columbus like you would like to have it, or the amount you would like to have it. And also intermittency is an issue. So storage will be very important. I would say storage will be even more important the more electrification we bring into the market, especially regarding renewable energy harvesting, with wind and sun being not very, let's say, very stable, because you have a night, for example, and at the moment we don't have so much wind. If you go then to geothermal, you might get here a much better, let's say, capacity factor. That's quite good, or even nuclear power is for sure a huge potential there to have less intermittency issues. But having them storage will be very important, and storage in form of hydrogen or other, let's say, synthesis based fuel or biofuels also additionally. So running with renewable energy, of course, you want to use that directly in your grids, but you can use it if you have a surplus of energy to go to electrolysis, and different or various application of hydrogen is possible, from re-electrification to mobility and industry, and additionally, as said, with the synthesis, you could also have a carbon capture technology to have a CO2 at that point also, and to have a CO2 neutral or low carbon energy in molecular form. So my first chapter, I like to end with this slide with let's say the message that diversity in energy, technology, and infrastructure are just as important as biodiversity in nature, because we also know that nature and monoculture are not good, at least in the agricultural sense. If you have a monoculture, you're destroying your soil and the nature itself. And even in the Amazon forest, you have a variety of plants and animals. Well, this is, let's say, or a message for diversity. Yes, on one side, we don't want to have monoculture, but on the other side, we also won't be able to address every technology, every energy harvesting we would like to have. So we will have to meet in between and have a set of technologies, energy at our disposal to have the best synergetical way energy. That was the first point on energy topics. And I would like to show you some life cycle analysis and stress out a little bit why these are important. So at the moment in Europe and the US also, it's only tailpipe-driven emissions. The EPA looks at LPA, but more to see the impact of their tailpipe emission regulation. So this is not, let's say, the whole story. If you look at it, at least you should have let's say the energy and fuel energy demand you need as a well-to-wheel analysis would be the least you should look at, because it is not only what comes out of tailpipe, but also what's the energy, also oil and fossil energy costed extra in energy before landing in a tank or in a battery. Please talk about batteries and electricity. Also, an electricity wind farm has its CO2 footprint, and that has to be also taken into account. But if we want to make it right, the analysis as an engineer or scientist, we have to go from cradle to grave. We include all raw material extraction and manufacturing of subsystems and vehicle manufacturing, up to recycling and recycling into, let's say, using recycled material already to reduce raw material extraction and so on. So this should be, let's say, in a simple way, life cycle analysis you need to look for. And I would like just very quickly show you some life cycle analysis, and I would like to start with this one, which was, let's say, ordered by the German Minister of Climate and Economy. And one interesting thing was that, okay, they were able in politics, I hope, to understand that there is a production footprint in the life cycle, a usage footprint, fuel and energy supply, and also tailpipe emissions. And at the end, of course, the recycling part and all the named here. So the message here is comparing in a simple way engine. You can see the carbon content of the life cycle phase here. If you look at combustion engine. Of course, the user time is the worst. The tailpipe emissions are the most relevant, but also small parts with the logistics and refining, also oil and power. For electric vehicle, it concentrates more, let's say, the energy or the CO2 footprint of electricity, and we are using here the European CO2 carbon footprint mix as an average value, which also is not always pointed to charge at night and have the sun at the same time. So at that time, the new average might not be as good, but talk. For an electric vehicle, the most important part is the cradle to T1 part, because you have lots of more copper, aluminum, maybe steel also in the parts, but also the battery as an extra chunk of CO2 footprint, which we in German call it backpack, CO2 backpack, which you start very early. You just got the car 0 kilometers and or miles, and the car already has a huge backpack in comparison to the combustion engine. And let's say message for politics was, as a result of the electrification, focus is shifted to the production phase. So we have to look even more thoroughly in all, let's say, tier 1 and tier X phases of getting the raw material till getting the vehicle. That will be a very important CO2 part. And there was parallel another life cycle analysis from the German Engineers Association, of the CDI, which shows this a little bit. The y-axis is the CO2 equivalent in tons. And you see here the conventional mild full hybrid plug-in hybrids. The gray ones are gasoline and diesel, which are the smallest footprints and widest because of the tailpipe emissions, the mileage, not the 1,000 kilometers driven here. If you take electric cars with large batteries, you have like more than double the CO2 backpack already from the start. That can be diluted depending on the quality of electricity used to become. Let's be optimistic and work with the average values, and then these are A, but at the end they are similar to plug-in hybrids, and all these combustion engines were driven without any renewable fuel assumption. So that would be also another positive way. If we could use e-fuels for combustion engine, then we will also be better at this point. For battery electric vehicles, we need green electricity, we need green battery manufacturing. So that is for sure one point we still have to develop. And additionally, plug-in hybrids are a good, let's say, mix between these two technologies, because they are allowed to use, let's say, green electricity and reduce the use of fossil fuel and be more flexible. That just to be very quick on these parts, because these might be known to you. I have something from EPA and from Argonne. Also here from an EPA study, the impacts depending on various, let's say, CO2 or electricity or energy regarding energy carriers and production for these kinds of vehicles, like battery electric, hybrids, plug-in hybrid, and some of the vehicles. And the GDP percentage difference versus pure IC. You see here, depending on the energy source, the battery electric vehicle can be extremely good or even worse than combustion engine. The same applies to hybrid electric, but more to plug-in hybrids. Battery pack already in it, and the fuel cell electric vehicle is also a kind of a hybrid with the Q1 hydrogen and a small battery. So also here you can see, depending on the energy source, you have different results. And at the best point, yes, battery electric will be in the future for sure the best way to go. But till we get there, I'm not talking about 10 years. In my opinion, it's more the order of magnitude of 50, maybe something like that. Till we get so much energy and infrastructure. Till then, we have to have, let's say, a mixed technology which bring us faster climate neutrality. If we look at Argon's results in a similar way, here in y-axis, you have emissions with current technology, future technology, and blue is the fuel burden, energy, fossil energy, or the electric energy burden. But you see also here the future technology for using advanced fuels, meaning also for a battery electric vehicle using wind, solar, like and other kinds of electricity generation. You see that, yes, if you look at actual technology, battery electric vehicle, even with a larger battery, is still better than a gasoline plug-in hybrids or fuel cell. But if we go down to the future technology, which I hope we as engineers, we have to understand past and present technology, and we have to develop the future technologies. We see that these are all quite similar. And if you are having availability of renewable energy, electricity, and also hydrogen-based fuels, then these vehicles are not so different in greenhouse gas emission. So I guess it's more dependent on the energy available. Yes, at the moment, in Germany, we have lots of renewables. Yes. So if you have renewables in Germany, I would say just put it in battery directly, not use it through other paths, because that would be more expensive than it is expensive. And to wrap up this LCA chapter, also some FKFS and Stuttgart results from our LCA tool, which tries to gather data from Argonne, from the ESP in Paris, from Stuttgart, David, so yeah, usually a lot of students taking parts, engines, parts, electric fuel cells, combustion engines, batteries, with common course to address these LCA databases much better and more accurate differentiation of materials. If we look at a realistic scenario today with 200,000 kilometers, you see, let's say, the production footprint, cradle to gate in dark blue, and let's say the thing like what the well to wheel, well to tank and wheel emission for the energy. If we look at sedan passenger car, we see that using let's say production is of course double the footprint, and using the electricity mix on an average in level, comparing to fossil energy, it will always be better. But if we can look in the future with today's technology from today's perspective and an ecological best case scenario, then we will have, let's say, I guess it's around 25 grams per CO2 kilowatt hour electricity, which is very good. We are, let's say, 10 times away from that at the moment. But let's think positive. If we take e-fuels from South America, wind energy and a blue H2, so with the still natural gas capture, at the end, depending on the vehicle, we are quite similar using these different technologies. So maybe it's good, yes, to go into electrification, but also looking at hybridization, looking at other energy carriers, and ICE here is already hybrids. This allows for achieving the same result as pure electrification with an electric vehicle, and maybe having the ability of avoiding bottlenecks like raw materials, infrastructure, that's again this last chapter. Okay, so let's start. We saw that energy and circular economy are very important, and we have to differentiate where the energy comes from, which raw materials we have, which production technology we use to assemble a car, and then we have to address also the energy we want to use. But let me start first with let's say, the amount of the world, and let me start by being European. Like, let's start with the European Union. We know that a quarter of the vehicles or the mobility in Europe is being accounted for the greenhouse gas emissions, mainly roads and 14% aviation ships each, and then trains and other cars. But basically, road transportation is quite relevant. That's we can take for a little more, and like that graph I saw showed you and said, well, this is very good. And so this is not directly greenhouse gas emissions, but this is energy consumption. And if we look at the energy consumption you need for transportation, it's basically petroleum or oil, fossil oil based, and a bit of other biomass, natural gas, and so on. But electricity are very, very, very low, 28%. So let's make it simple, say 28% of CO2 goes into transportation, also maybe plus minus percent depending on. But basically, also not so far away. So a quarter or a third of the energy goes into mobility. So it is really important to look at that. And we know that at the moment we have 1.5 billion existing vehicles. That's an interesting number. And every year, 90 to 100 million come additional into production. We have here, let's say, finance crisis here and pandemics. But this number is already going up again. So we are producing more and more. Then let's just take some very optimistic scenarios towards electrification and carbon neutrality 2050. And from my day, at this day, you can find lots of scenarios. Let's just pick a couple of them. Say in 2030, we will have for sure maybe around 15 to 30% of battery electric vehicles and pure electric vehicles. And maybe in 2050, it will be a larger number. But between the two main scenarios from IEA, you see, maybe 20 or 30 to 80% is what you can expect. So the scenarios are really so different. Let's be optimistic and say, let's try to extrapolate with 80%, 70 to 80% of any battery electric vehicles will there be. This is a new registration share. But if we extrapolate that to existing vehicles, this will be, of course, a very relevant chunk of vehicles being developed and brought into the market. And at the same time, I hope existing vehicle fleet is rising, but maybe it will go down. There are some studies showing that it might go down around 2040 or something like that, but it depends on the study. You need blood cells like breathe out a little bit at the end. This means that we will have lots of energy carriers, also molecular energy carriers, even being in fuel cell electric. This is hydrogen that has to be produced in a renewable way. So we will have to look not only at electrification of all powertrains, hybridization and fuel cells, but also the, let's say, the energy content of the energy carrier being electricity or let's say molecule use for energy storage. This means, yes, we have to concentrate on electrification, also electrification of every, let's say, combustion engine, and also fuel cell what does that mean? This is the future. Let's look a bit at the past. So this is the, let's say, the car, passenger car registration share worldwide first. Divided in car, battery electric vehicle, plug-in hybrids, and the full hybrid vehicle. And what we see here is that we have already an interesting share of electrification, pure electrification, and hybridization or parts electrification. That means that we still have almost 90% by ICEs being produced, and this will reduce, yes, but we still have a large production of ICE in the next years. If we look, for example, also to the European markets, well, the suspension base was the problem here. We have 13-14% of that electrics, and the rest also a lot of hybridization, and hybridization is quite at the moment. What we see in China is a huge phase by the electrification of combustion engines, or electrification, or let's say like that, battery electric vehicles with a combustion engine, which are getting very popular as range extenders, series hybrids, and combination of series. So this is quite interesting also to see. And we see also hybrids getting stronger and stronger. And when I talk to the people in China, they are quite pragmatic. They tell correctly, well, it's cheaper. I don't need charging infrastructure because China is very large. It's a huge country. To make infrastructure in this country, was from the engines department really told me directly, as a concern, see this large country, we won't be able to make infrastructure this. So electrification is very important because electricity is very cheap in China, but we need to assure that our customers can get to another city. They get or hybridization will be for sure quite interesting, and we have to focus also in IC efficiency, also for our future fuels. This is a kind of a view in the world. Let's take a quick step also in the German numbers, and let's say the German vehicle. We publish every month our registration numbers, and it's quite interesting. All the battery electric vehicles were very popular. Subventions which went out in 2024 got out. Now in 2025, the first quarter also already showed that this is correctly built. So we are going at towards 18-20% maybe. Let's see. Actually, the electrification is here to stay, and it will be very important, and it will rise. But we see also the, let's say, the light hybridization is quite popular in, let's say, making gasoline engines more interesting for the customers. And we have Mercedes doing a diesel hybrid. It is one of the most efficient cars ever. They can do an efficiency that really amazing. But it's more expensive. Of course, it's more expensive than the gas. Then you see the plug-in hybrids also because of going away of the suspension was an issue here. Then we look at some brands, for example, Mercedes, electro only, they said goodbye. They say electro first now again, maybe 50% by 2030. I don't know, BMW maybe being a all-time rival of Mercedes, they say yes, we will reach 50%, but 2029 we will be first or 1 year earlier than Mercedes. And when you hear Toyota talks, Toyota is of course very pragmatical, but also very careful with what they say. And they say, yes, of course in Japan it's not possible to run battery electric. They have 1 to 2% battery electric vehicles because they don't have a stable. It's not possible. project in electric car or equally are there, but they are the worldwide biggest manufacturer. And they know their customers want to have everything. Combustion, hybridization, plug-in hybrid now, also the previous things, so that's plug-in hybrid, fuel cells, and also battery electric vehicles. There are coming this year with three new models. They have all technology, but they know what customers demand. So they say, well, between 10 and 30%, like Japanese are, um, they don't want to tell you something that might be wrong. So they give you a new range. So 10 to 30% electrification by 2030. Well, let's see what happens. And looking at the EU passenger cars, the existing passenger cars in Germany, we see that, of course, electrification will go up, but these at the moment are, say, about 5% electric or 10% electric vehicles together. But electric, and this will continue to run, of course, and I foresee that we will achieve, maybe 20%, 10-20% in 2030. That means that we will need not only more focus on electrification, but also in renewable energy, electricity, and the energy barriers. So this is, let's say, perspective. We need electrification, but we all know infrastructure is very important. Because if you don't have a plug charge your car, electric car, then what you do? You have to search your patients as a customer. That's not a good way to reach a customer. So we have to look at the infrastructure topic for mobility of the future. Let's start by assuming we have only renewable energy infrastructure like sun and wind, just above. Of course, if you have electricity harvested, you want to use it in the grid and distribute it directly to your applications, your mobility applications for passenger cars and others. But you don't have electricity all the time, and sometimes you have exceeding or a surplus of electricity. Not using it would be not a good idea. So you have to store it. One way to store it is using hydrogen electrolysis and using hydrogen carbon storage or others. What it means to have a way of re-electrifying hydrogen electricity so that you have energy at your disposal day and night. Of course, if you have some time in the future such a surplus of energy, you could use that hydrogen to use the synthesis using CO2 from point sources or from direct air capturing and have methane, methanol, or gasoline synthesis. You could use the hydrogen directly, of course, but also could use the synthesis with methanol or fuel into your car. So being an e-fuel synthetic. So these are various possibilities of infrastructure is required to have, let's say, neutral mobility. But just to show you the European perspective on this, the Europeans said, well, 2030, we would like to have, let's say, everything electrified. That would mean for all kinds of vehicles, from small to long-haul vehicles, we would need in Europe like almost 90,000 kilometers of new grid infrastructure. What we have and available, considering technical bottlenecks, and here is availability of manpower, technology, everything that's you need to set up, let's say, a plant or put cables to the country to distribute the electricity. That is already 80% less of what we have. So, and what we actually have planned is even less. So what politics wants to have is pure electrification by 2030. That is by a factor of 10 not possible. So we have to look at additional topics because this needs like to use this picture because this is apparently they started the things very around and having been at Porsche, it's nice to have the engine in the back in the 911, yes. But if you do electrification, you have the electrification of your cars, you better electricity, you have to bring up the infrastructure at the same time. So just putting, let's say, the carriage in front of the horse is not the solution because now we have great products, great electric vehicles, but many customers don't know how to charge them. That's the main issue. And this slide is the summary of the small chapter. This was a study done in Germany with energy providers, OEM, tier one suppliers, year-wise. We were at Porsche also we called at that time when I was there, and they tried to do single scenarios for climate neutrality for mobility. And they said, okay, let's do a PHEV strategy or complete domestic battery electric vehicle strategy or battery electric vehicle internationally. These curves take a long time because you have to build up infrastructure, build up wind plants, farms, the photovoltaic parks, and so on. And all these take time and take also CO2 backpack with that because that's why the curve takes a lot of time to go up. And then you have also MTG or fuel methane plants or H2 combustion or fuel cell electric vehicles. What they did with this model was to also see which bottlenecks. Where do I get the raw material? Where can I get the infrastructure built up, the manpower, and other technology bottlenecks? And the result of this study was we need a parallel roll-up of all powertrains. And this was the big scenario. We want really to tackle climate change quickly. Then you cannot just focus on battery electric vehicles. You have to focus on other technologies to avoid bottlenecks that come with looking at the scenario which comes from raw materials, infrastructure, up to building the products. So we need diversity, but let me start the point of electrification and some very important potentials that come with electrification. Some facts on the right, you see a Raphel diagram, so specific power kilowatts per kilogram, or specific energy megajoule per kilogram. And you see in the first part that, let's say, molecular storage carriers are much more specific dense than battery technologies. In the future, we will continue to have, and we need this battery research have better and better batteries. It's for sure we have to do that. The next 10, 20 years will be very, very interesting at this point. But we also have to recognize on the other side, electric is one of the best engines you can do. It's the best torque and power specific density you can have in comparison to combustion engine. It's a really great subject there. But efficiency and power are not the only parameters when you as a company are going to decide on a product. You also have to do some cost and so on. And see, yeah, the battery electric vehicle is 3 times more efficient than, let's say, efficient hybrid configurations when also run fuels having a higher potential and then the difference to battery electric vehicle might not be so large. So that diagram shows the efficiency, both fuel efficiency on one side. The right side, cost that. It was caused by driven developer, showing that between let's say of course a car or a truck is of course very different. But if you look at e-fuel combustion engine or a fuel cell, these are quite cost competitive, even having to produce hydrogen, which is expensive, going to ethanol process, which is also not so cheap. But at the end, if you put everything in with infrastructure built up and all these necessary costs associated with it, then they are quite similar. So maybe cost would also motivate to look for diversity in the technology and energy. And regarding time, I'll just go very quickly because I guess it's much better lecture on electric than I can do. But basically, some of the most interesting machines are for sure permanent magnets, which we were with the ones to reduce the rare earth usage. On the other side, also several we highlighted signals and engines are very interesting because you spare the magnets need for that. You can also go with induction motors to avoid the magnets or future reluctance engines. We just need more then get or and maybe just focus on some different let's say developments for sure. The electric motor developments in the last 10 years for automotive purposes, there has been a lot of developments in hairpin windings and also direct cooling, stator cooling, rotor cooling from the inside. So there have been any interesting developments. On the other side, all the potential you can get with the carbon and so on. It's quite interesting to have less losses for electronics and very important for vehicles for vehicle integration, putting an electric motor with the cooling, with the gearbox, with power electronics, everything in such ways integrated that the packaging vehicle is very attractive. Motivation to buy. As already mentioned, there are many possibilities of reducing here Europe with reduction sheets. BMW had already a solution, or now has wireless reduction system. Others interesting developments on this side that would be, of course, be also a trend next years. And at the moment, many electric motors application are coming with develops. And one last slide, maybe advisory. Excel plus definitely. And just let's say tried to motivate like the Excel plus machine complex from a manufacturing point of view. That your saver is in the middle and the rotor is only let's say like that. The interesting thing in that performance and torque on the radial plus machine is rising with the diameter in quadrant, where the diameter with the length, and the axle plus machine is the meaning for a certain diameter, the axle plus machine will be much more performant and meaning also much more interesting from packaging and weight for the same 250 kilograms. The axle plus machine is almost a third, only a third of the weight, and much more, much less packaging volume. which makes the integration water architecture. So just to give an overview, electrification is very, very important and very interesting. Has lots of new topics from batteries, electric machines, and also power electronics. There are many topics to work on. Additionally to that, electrification in the hybrid setup are also very interesting. And this is the old slide that they focus this at that time it was like the P0 was the start of technology, the P2 configuration, the actual parallel hybrids, or the Swiss hybrids, like the three or the series hybrids, which are very popular in the Asian world, or series parallel hybrids, which are also interesting. Chinese also look very strong at P1 and P3 hybridizations, which are very interesting for more city-like applications. In Germany, one was also always looking at the autobahn, the high speeds. So that's why for those that are not interesting, but they will for sure be interesting. And one project I would like to show that was my last project that's Porsche doing the 9X changing combustion engine under one concept with a motorsport hybridization in P1 not only fast but structurally the tank with an additional electric turbo with an electric machine compressor and turbine so that at high power he's producing electricity back to directly let's say it's heat recuperation in electrons. We eliminated the wastegate or any other heat from charging. So we have to break the turbocharger and produce electricity to have the right, let's say, pressure. And that is at the same time producing electricity for the motor. And having, let's say, looking at additional potential for hybridization, we had an MEP project also as the methanol high efficiency engine, often extra technologies from downsizing, tumble content, the variable wall time, compression, EGR, and running methanol lean concept with very high efficiency, very mean efficiency. And putting this engine into a P2 hybrid configuration on the BLTP or driving fusions out, we were able to achieve 50% heat efficiency because the methanol lean engine was running always in only very good efficiency or not, and the efficiency, let's say, during the engine running phase, if you run the hybrid combustion engine was not needed, it stopped, and we could, with let's say, energy recuperation, compensate and achieve with this kind of application. It's a very high efficiency. But talking about IC engines, you have I took from some slides and from you also. You have for sure. We have done lots of technology in the past, and there are still lots of technology to be addressed when you talk about internal combustion engines. For sure, making IC engines dedicated for hybrids applications and operation strategy, or going on the outside also to maximize efficiency with advanced combustion, pre-chamber or type combustion concepts, or going into hydrogen or methanol technologies. like, for example, Orally or UV-based technologies, they try to take everything into account, and some of these technologies I already talked about in the slide presentation, and they want to go into ultralight, high compression ratio, ultra-long stroke, internal combustion, emissions topics, and fuels like methanol and hydrogen. And they are trying to achieve more than 44% of their ratio. If you look at Japan and from, let's say, the corporation ICE and NTV in Germany, they like to also address these kinds of technologies, looking at, of course, firstly, looking at electrification, meaning hybridization as a base equal, then going into a peak efficiency improvement with lean combustion, heat loss, friction loss reduction, waste heat recovery, and then with hybridization operation strategies, even go lower both fuel or fuel efficiency, and then at the end address the rest of CO2 with the carbon neutral fuel they sell, and for them it's equal and together, and have a kind of a CO2 capture to have this circular economy. And yeah, lots of these technologies a bit say hours and days talking about these technologies are very very. So maybe to wrap up the talk, I'm already reaching 1 hour slowly. So finished with the synthetic fuel plant, and being at Porsche, I worked on the electric side, but also on the e-fuels side very thoroughly. And we put, let's say, a single plant there to have the possibility of showing off that it is possible to do it. And at the moment, there is one windmill, but in the next 5 years, there could be like 500 at the end. Basically, the electrolysis with renewable energy from air capturing, methanol synthesis, and then methanol gasoline, all of the to get the kerosene, methanol for various applications. You always get stream of hydrocarbons, so you cannot just do aviation fuel. You cannot just do marine fuel or just passenger cars. It's not possible. You always have green carbon. You have, if you want to really have a sustainable aviation fuel, you have also to have e-fuels for passenger cars and use them and try to create them. And in Stuttgart, we also did all the calculations, all the energy and material used on energy streams, from electric energy into the electrolysis, going to the direct air capturing, the CO2 for the reverse water gathering process, and the methanol synthesis, and all the heat coming through that, using in all possible synergetic ways to have island plants capable of working without any additional energy than just little standing. And what we found out is, yes, if you look at geothermal power, you have the possibility to reduce automobile emissions from fossil fuel down to 80%, just with today's technology. Porsche, we saw that it could be more. And in Iceland, it's the geothermal is amazing, yes. But the insecurity of this bars comes because of the holes drilling for the geothermal could hit natural gas pockets and natural gas and impact on that all the time we will consider it. That's why these high. That was also. We try to see, let's say, also the cost, life cycle costing in this fuel, and we don't look at profit margins, taxes, or subsidies, and so on. You could get, let's say, around 1 to 1.5 euros per liter for an EV. That is, I would say, competitive. And these are prices we have standing 5 or 10 years or 15 years. It will be quite interesting to bring into the markets. If fossil fuel with CO2 taxes raises, then it will be quite. And the cost derives mainly from the renewable energy plants. So using wind power is the windmill, the half of the cost of the fuel. And if you go into photovoltaics, it's more expensive, and that's is cost share you have. So you want to do an for hydrogen based fuel. You have to go where your renewable energy costs are very low. That's why we didn't make it in Germany. It's like 5 cents per kilowatt hour for the, let's say, for access cost of a plant. And if you go to Chile, you have 1 or 1.5 cents per kilowatt hour, which makes it very effective. Okay, so I'm coming slowly to the end. I wanted to just show some results. And when we were in the population development, we saw that both from the EQ production side and from the side of engine operation, we have different demands. The production side wants to produce it simple and cheap. And the engineer, the combustion engineer, wants to have an amazing motorsports fuel. And this is not very near goals to achieve these goals criteria. So we had to have some iterations to come from production evaluation. We did some, let's say, machine learning topics on from the emissions co-starts to performance topics to see which hydrocarbons are best for the combustion and how we can choose that production for the that's we had some results, and I just will focus on one and then have an essay paper that is comparing a reference fuel around 98 fuel, which was again compatible to the European norm for gasoline. And we had other, let's say, ethanol modification, and at the end, synthetic fuels. Being one of them even more compatible, meaning we could use it right away in our cars, so in every car, which was a bit better than 104, better than cost. And that was also one interesting thing from analyzing low speed with an engine with pressure ratio. See that the black curves are the reference fuels, all going into knock, going into later combustion anchor angles, which uses efficiency, of course, and the ones here, the light blue ones, yellow, and the non-compatible fuel, showing very high efficiency and very low particle emissions. So this was quite simple. Still have some further quantified fix, but I'll just go to the so what I want one possible vision is today we focus a lot on electrification, and that is very important. So we should not forget the audit because we will need them all. And it's understandable by living at the moment very expensive renewable energy. Of course, it's difficult to think else than using that electricity directly in the battery. I fully understand that, but we will have to focus in a broader way into electrification. Each 2030 electrification, hybridization, transportation, but also in form of hydrogen and hydrogen-based vehicles. And I'm pretty sure, looking at many, let's say, energy plants, renewable energy plants being set up, that we will have a surplus of energy. And we will have to store it in some way, and it won't be all batteries. We will have to have hydrogen-based storage needs, and maybe then also in terms of e-fuel and methanol. I'm pretty sure that methanol will be, let's say, the new oil of the future in, let's say, 20, 30 years, if we are able to displace fossil fuels, and the next energy carrier that comes nearest and is known by its own methanol as a start for every energy carrier. So I believe in an electrified and hydrogen-based mobility and storage future, and these look like these three main classes of powertrains and energy carriers. So fully battery electric vehicle or light-duty vehicles are definitely very important. But we also have to address with renewable fuels, electricity, also hybridization, maybe not only e-fuels, but also using hydrogen in combustion engine, energy intensive applications, so also heavy duty, especially also for electric vehicles, the applications quite interesting. And sorry about the Porsche images, but it's these applications are not only but going into heavy duty or energy intensive applications. We will need, of course, energy carriers that are much more practical than using large battery vehicles. And with that, I would like to close with some takeaways. And it's, I would say, the future will be an electrified mix of technologies. And we have not only to look at the powertrain, but also the energy source and the energy carrier. And we have to look at the infrastructure build-up. These bottlenecks have to be addressed, or else we can raise electric vehicle, which is an amazing thing. Yeah, but if the customer again doesn't buy it, it has still be achieved, not much. So we have to look at all topics, all bottlenecks, and some set of rules. People want like some use renewable energy and electrify everything you can. And if you can't electrify, but not hydrogen, and if not, then fuel or hydrogen. And of course, you need this let's say diversity in applications so that we get efficiency. And most of all, we need motivated and skilled scientists and engineers to tackle these challenges. And that would be finished. Thank you.
Thank you. I am going to slip into my next meeting, but please stick around and speak with Professor Poulter. If there are any questions online, please stay. Will be my office. Very nice. I like to share in 2010 seminar I gave sometime, because I think we're going around in circles again. Of course, we know a lot more, but we agree. And this no silver bullet is something that some of us have for a long time. But awesome. Thank you, Andre. Very nice. Come on up, guys. Let's schedule it.
Can just an easy round of questions and stuff if you want. Yeah. I will wait.
Thank you for the presentation. It was really good and informative. One question is about the contribution of other technologies. What do you think that you said electrification is one of the most important things, but what is number two? What is number three? Four? Like what according to you is Like, we can't go on each because each technology has its own ecosystem that needs to be developed.
Yeah, that's also it applies to companies that can't do everything. So they will have to do electrification, something else, and maybe hybridization is also very important, especially if you look at the Asia market. They are just exploding. Let's say the battery electric vehicle is between 25 and 30% stagnating and growing slowly. It's growing slowly. And hybridization is passing 40% now. It's amazing. They are hybridizing everything. So after pure electrification is electrification in form of hybrids, series hybrids, plug-in hybrids, parallel hybrids. This is very interesting. I hear myself.
Yeah, I think there's an echo coming from.
So we have another mic. Anyways, yes. So basically, the hybridization is very important. If I would look as a company at the market, like Toyota, they are quite smart, I must say. They analyze what do my customers want and what is the demand. And they started in the 80s, 90s with electrification, with hybridization. And at first, let's say, if you look at the aesthetics, the first view was not so a nice design, but it was, let's say, developed in the wind tunnel, and the design was not so appealing, let's say like that. But they stayed with it and evolved to a way that they understand hybridization very well, and they see that is the main, for them, the main product in the market. So I guess in Germany, I find it's quite bad that the hybridization isn't that popular like in Japan, because now we would have a huge potential of addressing that. Hybridization, very important. Then, like I showed in one of my last slides about the use of the ports. So this is a bit, let's say, my hidden recommendation. Electrification for sure. Hybridization is at the moment, I guess, one of the most interesting technologies because it paves the way towards the pure electrification and gives you the knowledge of electric machines, power electronics, batteries, without having to go full in on battery electric. You could argue battery electric is easier because you don't have to make a complex system with a hybrid combustion engine and so on. But it paves the way towards electrification. And at the end, also, the fuel cells could be, let's say, a third path to go, because you will have the energy-intensive applications, buses, trucks, I guess, class 6, class 8 trucks. If you have like 10 tons of battery in it, it's you cannot use. So we would have to have more trucks to compensate those big single digits tons you need in batteries to run a battery electric. So I guess there is a chance where fuel cell electric vehicle is very efficient and you have much lighter vehicle, cost-wise also quite interesting vehicle. Depends also, of course, on the infrastructure you get. You need infrastructure for electrification, megawatt infrastructure, charging infrastructure for a truck. But on the other side, for a fuel cell electric vehicle, we need hydrogen infrastructure.
Exactly.
That depends on the application. If you have a fleet that is near a harbor where you have the hydrogen production, then it's perfect. Then use hydrogen. If you are somewhere else where you have a lot of I don't know, nuclear energy or whatsoever, you have much electricity that run electric. So that will be, I guess, quite different. And what I tell my students is, but it's good to understand technologies, all of them, because we never know which one will be popular one time. So also the combustion engine in a hybrid configuration will continue to be very important, even if at the moment it's not very popular. So I'm quite pragmatic about it. So we will need everything, but yeah, focus more on electrification and the
And like my question was regarding that only, like because each will have their own ecosystem. And on I think slide 34 you presented there is, if we just focus on one technology, it will take long. But if you do optimal, like it's shifted at like what, 10, 20, 10, 15 years, like, that will also require like all you will have to work on all the ecosystems development, all the technologies. So how can it be so early that it moves like from, if we focus on one, like, well, there's an optimal split that, oh sorry, there's an optimal curve that you had.
Yeah. Yeah.
Got moved so early.
Exactly. That's why you won't be able to electrify everything at the same time. You need other technologies anyway.
Yes.
So just doing one won't be enough. And we see that at least in Europe, electric cars are very good. We have now from Mercedes, Porsche, BMW, Audi, we have great electric cars, but customers don't buy them because if you already have one, well, you have one already, and if you don't have a house with a wall box where you can charge it, or a workplace where you can charge it, then it's a challenge and it's not quite attractive. You want to go to snow or to the hills or whatever, where can you charge? So these issues have to grow in parallel and not only put the car there and say it's a great product. It is, but the customer needs also the investment. So that the next 10 years will be quite interesting.
So first of all, Ivan, it was really super interesting presentation and super well presented. So really interested to follow all the path from the beginning to the end. I wanted to ask a question connecting to Apple One, but focusing, let's say, on a different aspect. If you can go to one of the first slides, I don't remember if it was 3 or 4, where there is the projection according to the IEA
Yeah.
future.
This one.
Oh,
Or to-
no,
or
without
next slide.
this one. This one. So okay.
Yeah.
So I perfectly agree with you that let's say we should follow different paths, and I'm again like the typical phrase of Senegal, the future must be like if I wasn't that way, Federico would have pardoned me many years ago. So I should not work there.
Yeah.
But one thing that really catch my eye from this slide is that from what I see, in 2030 there is like more variability, and then 2050 is going to be almost all electric. So, for example, hydrogen that according to what we were seeing before should be one of the technologies followed.
So there.
Seem to phase out at the end in the 2050 again because the other one is biofuels or hydrogen.
It's hydrogen. It's here it's biofuels. So we want and here it's
Oh, okay, got it. Okay, I thought I also
so it's
from here.
hydrogen is coming later.
Okay,
Yes.
okay, I inverted the colors from here. I didn't see it well. Okay,
So biofuels is the availability is now,
okay,
and you will need it anyways for for let's say energy intensive applications where you need a liquid energy carrier which is much more energy intensive than batteries or hydrogen. So biofuels, you will always have a share of that, and hydrogen is what 2050
okay.
is going towards heavy trucks.
No, now it makes much more sense. When I saw it from here, because it's really
Yeah,
small,
So,
yeah, I thought that it was opposite. So I was really like shocked that hydrogen was not playing a big role in 2050. No, but now it makes much more sense.
it's displacing biofuels
Yeah,
a little bit, or using biofuels anyways, but adding hydrogen to that. Because you cannot electrify everything.
yeah, got it. No, thank you so much. And then the other question is more a curiosity, because I imagine from your background, your main expertise was fuels at Porsche, right? And One question that I have for you is because I'm a big fan of old cars.
You
Yeah, vintage cars. Like, and I know that if you look at number percentages, of course, those cars not have that huge impact because they are more fleet. They are used occasionally, not every day. So if you look from a bigger perspective, the contribution of those cars to the worldwide CO2 emissions and other emissions is quite negligible.
Yeah.
But one of those cars, even if they're beautiful and we love them, actually it really impacts. I heard that there are studies that are also trying to develop some uses. Do you have any knowledge like also about Porsche, like of some fuels that are being developed for those type of vehicles that can substitute like conventional gasoline, and so can make those vehicles more sustainable?
it's Porsche, the goal of being the e-fuels is also to address all plastic.
Okay.
Like in the beginning, I said 70% of the Porsche cars are still on the road.
Yeah, exactly.
One of the goals is to have on Porsche experience centers or for customers that they can buy carbon neutral fuel to continue running their classic babies.
Okay.
It will be compatible. We had one 1993 Porsche from 911 from the 90s, also being tested with these e-fuels on the roller test for emissions, and the result was better. The fuel is better in it's had some goodie like a lower final point, and some better, less aromatics than the classic fuels. That is all helping that you have less HT and less particle emissions. Even vehicles with an old catalyst. So the fuel itself is already emission reducing, especially for the old.
Okay.
So that is also an added benefit for that. What is quite serious about that? I know that also Bugatti Rimac, Ferrari, and others are looking into that.
Into that. Okay.
Even at till the point, well, this is already unofficial, till the point that they want to guarantee the customer a fuel for the lifetime of the vehicle he's buying. He knows that he buys a nice V12 or whatsoever, and he gets the carbon neutral fuel with it. He buys the fuel with it. You don't have to go to the filling station and use the fossil fuel if you want. These strategies are being developed.
Thank you so much.
So I drive a naturally aspirated car for a very good reason. I don't want the hassle of having a turbo and its maintenance. And I do not want an electric car as well because my most common travel is from Columbus to New Jersey. There are like 15 Tesla superchargers on the road, and they're always full. So if we have e-fuels in the future, then can we expect that, okay, for people who drive like old cars or drive like sports cars with naturally aspirated engines, can we expect like better compression ratios in the future because the fuel is getting better and it's less likely to knock on the engines?
Hence, let's say while developing an e-fuel, we looked at those issues. Preparation quality, so preparation, fine boiling points, hydrocarbon mix, try to reduce not having the large we look at course, we put some knock like ETB and PB. We try to avoid a bit of ethanol. Because ethanol has such a huge evaporation methodology, good for say, but it's really bad for full start. We looked at everything, full start till full load, of seeing it was twofold. One is to gain acceptance from politics, public, customers, whatever. It has to be easy. It's like you said, you have 15 Tesla superchargers that they're all full. That's not easy for a customer. So easy for a customer from the point of a fossil fuel or a diesel, it is it has to be a fully compatible gasoline fuel. So that you don't have to choose an extra place you have to go to get it. So first generation fuels, we thought it have to be gasoline compatible, completely compatible to get the acceptance. After that, you can think of a second generation motorsports designer fuel,
or even second generation engines.
then you could go in that direction. Let's say motorsports do that. We have some projects with former times with World Endurance Championship, now with Formula One, MotoGP, and so on. These are petrol fuel. They're starting finally to look also at carbon neutral fuels, and that is quite interesting. And that is one possibility of having, let's say, a high performance engine, maybe for the public or custom, with a second generation fuel. That could be possible. It could be also possible to run directly with methanol, which NASCAR ran like 15 years ago in the US. And unfortunately, because the driver caught a fire in the car and no one saw it, because methanol is so pure that you don't see the flame. That was bad, and they finished then the methanol with that. Methanol is an amazing fuel, amazing energy carrier. The only problem is it carries half of the energy density, but yet you can compensate that with a bit of efficiency and so on. And it is storable, transportable. It's really no issue. It's easier than transport ammonia or lithium. These are much on the dangerous scale. They are much worse. Ethanol is like a gasoline. Neither ammonia or lithium. So I guess methanol could be one of these design generation engine design. And did I get your question right?
Yeah. I am just trying to run my Acura as long as I can. It's the last naturally aspirated one that Honda made.
Also natural aspirated, of course. I also have some very nice. Okay, so I don't know further.
It seems the question from the,
That was at the beginning.
yeah.
So
Yeah.
ask. Thank you. I guess I leave the presentation at the PDF, so I guess Ben and distribute or George or
Thank you.
Well, just